Today, over 50% of the world's population lives in urban areas. A proportion of that is expected to increase to over 75% by the year 2050. Cities are growing, and their infrastructure networks have to grow too. Residents want to live a connected life in a smart city where they are always informed and able to communicate, whether they are at work, home, or play. Having a flexible and easily upgradable fiber optic network is a must. With the construction method of microtrenching, city planners and engineers can best leverage overcrowded utility corridors and right-of-ways. Step 1. Planning phase. Determine the route, depth, and restoration method. Governing agencies and municipalities may stipulate certain materials or design criteria that should be agreed upon prior to design or beginning any construction. Ensure that all parties agree to a material specification for reinstatement of openings in roadway surfaces. Step 2. Trenching phase. Partner with a reputable equipment supplier and operator if you don't have specific experience with saw cuts or microtrenching. Cut the route to a predetermined depth and width according to approved plans. The proposed route should be carefully determined, avoiding utilities and obstacles that would require cutting the conduit, keeping the route as straight as possible. The specially designed saw blade for cutting into asphalt, concrete, or rock cuts up to 24 inches in depth and a maximum of 3 inches wide. It is connected to a vacuum truck or trailer, which removes any spoils, dust, or dirt, creating a neat and tidy construction site. Step 3. Pathway phase. Duraline manufactures a wide variety of high-quality conduits for pathways. There are 2 easy steps to determining the best Duraline product. First, decide the fiber count needed today. The outside diameter, or OD, of the fiber cable chosen will determine the optimal fill ratio and microduct size. Duraline recommends a fill ratio between 50 to 75%. Second, choose a configuration to accommodate today's needs and leave empty pathways for future expansion. If your design has specific requirements, Duraline can customize a product to fit your special needs. Ensure the route is free of debris, then place the microduct into the microtrench. Follow the placement with a shovel handle or similar item to push the microduct to the bottom of the trench. If the trench is rocky, placing a layer of clean sand into the trench will help prevent sharp rocks from deforming the microduct over time. If the route requires a turn, make several gradual cuts and, if possible, undercut the corners so the microduct bend radius is not exceeded and it transitions with a natural bend. Prior to restoration placement, it is recommended to place a layer of sand or foam backer rod. A 1-inch layer of sand or flowable fill will serve as insulation and can also help anchor the conduit if a liquid reinstatement material is utilized. Sand can also serve as an insulator if hot asphalt is used as the reinstatement material. If a fluid reinstatement material will be used, such as a flowable grout, it's advisable to anchor the conduit into the trench. Step 4. Restoration phase. Choosing the reinstatement material is the most critical consideration with microtrenching. Restoration, by definition, is the process of returning something to as near original condition as possible. Poor restoration causes issues like uneven settling, causing safety hazards to humans and animals, potholes in the restored surfaces, improper bonding allowing water penetration causing undesired soil movement or frost heave. There is a wide variety of reinstatement materials available, and each product should be evaluated for the location and environment. Reinstatement materials need to bond to the side of the trench and flex with roadway movement due to both pressure and temperature fluctuation. Colder climates and high traffic areas require special consideration. Backfill the trench 2 to 3 inches at a time, tamping between each layer to ensure equal pressure on all sides of the conduit. Ensure the backfill utilizes dry soil or time for drying prior to sealing the microtrench. There are 2 reinstatement material choices. 1. Asphalt. If asphalt is chosen as the restoration material, the conduit needs to be shielded from the hot asphalt mixture during the cooling phase of the asphalt. This can be accomplished by placing a layer of sand, flowable fill, or a foam backer rod. Special care must be taken to limit the heat transfer from the hot asphalt to the conduit. 2. Concrete slurry or thermosetting MMA resin. Concrete slurry or thermosetting MMA resin provides a more aesthetically appealing finish. They include special bonding agents that limit water migration in the trench. In some cases, the trench depth can be reduced with this method when compared to asphalt restoration. Once the conduit pathway has been placed and the restoration process is complete, the fiber can be installed into the pathway. Typically, the fiber is air-jetted or pushed short distances into the pathway. For more detailed installation information on microtrenching, please request more information from Duraline.